Hey folks, welcome back to another video. Today we're looking at question 1302, deepest leaves sum. The way we'll be approaching this problem is by using DFS, and the reason why we need to use DFS instead of BFS is because we need to get to the last level and get the sum of that particular level. And if you use DFS, we don't really know which level is the last level. So that's the reason why we use DFS. So let's get started. The first thing we need to do is actually look at the base case. If the root is equal to null, you would just return 0. If not, we need a queue, which is needed for BFS, and it will store 3 nodes. Let's call it queue, and it will be of type linked list. And the first thing you need to do is offer the root to it, and let's initialize a result called sum that you will be returning in the end. And we have a while loop that says while the queue is not empty, keep doing those computations, and once those computations are done, you will just return the sum. Nice. Alright, so as soon as we know that the queue is not empty, the first thing you need to do is get the size of the queue. So let's do that. And the reason why we're doing this is because while we are in this for loop, we're looking at a particular tree node that's given to us, and we add more nodes. So the children nodes of the nodes that you're looking at right now, and to make sure that you're looking at the nodes only from the previous level, you need to keep a track of the size. So that's the reason why we need to get the size of the queue. Is less than size, increment I, and you will initialize a new node called current, and you will hold the queue to get that, and you would add the sum, you would add the value of that particular node to the sum. However, before we actually jump into the for node, we need to set the sum back to 0. And the reason why we're doing that is because as soon as we know that queue is not empty, we know that there's another level to it, and there are other nodes that we need to look at. So to make sure that you're erasing everything else that you've seen previously and looking only at the current level, before you look at all of the nodes at a current level, you need to make sure that the sum is set back to 0. So that's the reason why it is set back before every single iteration. So you've added the value in the current node, and you need to check if the left node of the current node is not equal to null. You'll add that to the queue, queue.offer car.left, and you would want to do the same for the right as well. It's not equal to null, queue.offer car.right. Perfect. Awesome. So let's compile this and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. Let's talk about the space and the time complexity. The time complexity of the entire solution is of n, where n are the number of nodes, because we have to go through every single node to get to the last level. And the space complexity is also of n, since we would be holding all the nodes at a particular level within the queue at a given point of time. Awesome. So that's the solution. If you have any questions, please let me know in the comments below. Don't forget to subscribe. I would really appreciate that. I'll see you all in the next video. Peace.